Okay, this is 2.4, video 2. So this number 12 says the table shows the university's budget in millions of dollars over a 10-year period, where X equals 0 represents the first year in the 10-year period. So year 10 is actually at the 9, because each number will actually represent the first year totally completed. So we want to use the graphing calculator to create a scatter plot, so that way we can see how the data is represented. And so pay attention. I want you to be able to use this calculator and use it well. All of these buttons along the top are for the graph, and so we're going to end up having to use these to be able to create that scatter plot. But first, we're going to enter in all of these values for X and all of these values for Y under that stat edit. Okay, so I have them all entered in. L1 is all the X values, L2 is all the Y values, just like we did when we were doing linear regressions. Okay, then once you have them all entered, we want to make sure that we can see them on our graph. So if you go second, and then we want that stat plot, so we push that button. And you need to make sure your plot 1 is on and mine is off. So I'm going to push enter and turn it on. And then if I go to graph, it shows there. But yours may not. Your window, let me reset my window. Your window might look like that. So when you graph it, it might just look like that. You can't see anything. And you can zoom. See this zoom button? You can zoom in and out. The only problem is it zooms with 0, 0 in the center. And our graph is completely in this first quadrant. So the farther out we get with that in the center, it just makes it so small and pushed together we won't be able to see our graph well. So if you go to window, it lets us change these units. See, this goes -10 to the left and -10 units to the right. Same thing with up and down. And if I change them, I don't care about the X's. I only need to get 0 through 9 to fit, and this is going all the way over to 10, so that'll fit just fine. But and then I don't have any negative Y's, so I really don't care. That -10 is fine. But this maximum 10, I get all the way up to 150. So I need to make sure my Y values can at least get to 150. So I'm going to actually put them at 160. Okay, and then I push graph, and now I can see those points. All right, and then it asks which better represents the data, a line or parabola. And I would definitely say a parabola, because you can kind of see the curve there. All the data is decreasing and then increasing. There's no other drop, there's no scatters all over the place just leading in a straight line. It is decreasing and then increasing. So write that out. Parabola, you can put something because it's in the shape kind of a U or something like that. I want you to explain it in your own words, but that's what best represents this data. Now I'm going to use the regression feature to find the equation of the best fit parabola. Now when we did it before, we went to stat calc, and we would use linear regression, which was number 4 or number 8. Most people, we found 8 first, so the 8 was what we used. But we are dealing with parabolas, which are quadratics. So this quad reg, that's quadratic regression, we want that button. So we're going to push 5. And just like when we did linear regression, we just calculate it. And it gives us a quadratic, y equals ax squared plus bx plus c. That's standard form. It gives us a, b, c. And for this purpose, we don't really care about the r squared. We just want that a, b, and c. So I'm going to use that a, b, and c to write the equation. So I'm going to have y equals 1.49 x squared, because I plugged in, it says ax squared, so a times x squared, plus b, which is 0.51 times x, plus c, which is 39.98. All right, now it wants us to use this model now to do these next two things. So I no longer care about this data at all. Okay, that data was to help me get this. So on my my calculator, I'm actually going to turn my points off. I don't want to see those anymore because I'm actually going to put this equation in. And if I put this equation in and I can see my points, my graph just gets a little busy. So I'm going to go ahead and turn my stat plot off. I just click on it, click off. And then I want to enter in this equation. So y equals 1.49 x squared plus 0.51 x plus 39.98. And then if I go to graph, I no longer see those stat plots because I turned it off. But there is my parabola. Okay. Now we want to predict the budget in 11 years. Now, the years is up top. Okay. And for this to be a 10-year period, I'm at 9. I'm not at 10. Although, so 0 is the first year, 10-year period. So for 11, I'm actually going to put in 10 instead of 11. So if you end up putting in 11 just because of the graph, you're fine. But we're going to plug in 10. So, excuse me. So I'm going to just take this equation, 1.49, 10 squared plus 5.51 times 10 plus 39.98. Okay, you can just type that in your calculator, and I'm going to come back to this graph in a minute. So I'm going to quit this for a second. 1.49, 10 squared plus 0.51, 10 plus 39.98. Enter. So I got 194.08, and this is in million. It's the budget, which is in millions of dollars. Okay, so in 11 years, I expect it to be about there. So on my graph, if you're not sure about that, you can always push this trace button and scroll to when x is close to 11. It may not get to exactly 11. And yes, it'll have to zoom out just slightly because our graph only went to where x was 10. What is happening? Nuts. Sorry. My graph is zooming incorrectly here, or my window needs to be changed. Okay, sorry. So you can trace, see where it ends up. Now we want to use, because I was scrolling past 10. That was part of the problem. Okay, so yeah, change your window so that can fit on there. But use the model, this equation in part B, to predict when the budget is 5 million. So again, if you can change your window to where your y values can actually get all the way to 500 and trace it, you can see, let me see if I can do that real quick. So I'm going to change my window. I want to get to all the way to where that's up to 500 million, which is just 500. I'm just going to get it at 500, graph, and trace, and that's not what I wanted, but it will zoom. Okay, here we go. Whoa, there, it changed again. Okay, so all the way to 500 here. Ooh, it's going fast. All right, so there's 501, which is really close to 17.4. Sometimes it'll be exact, sometimes it won't. So, but if I scroll down, it's all the way down at 493. So there's 500. So I know 493 is 17.3. So 501 is about as close as I'm going to get. So I can tell the answer for this is going to be 17.4. But if you don't want to use the graph to do that, you can plug in 500 for the y equals 1.49x squared plus 0.51x plus 39.98, and you can use the quadratic formula to solve this. And just remember, the quadratic formula was negative b plus or minus the square root of b squared minus 2 times a times c all over 2a. Okay, remember, you got to set it equal to 0 first, so we would subtract the 500. So for this equation, we would use 0 equals 1.49x squared plus 0.51x minus 460.02. So C is actually a negative 460.2. And you just plug them into this. We keep the positive answer. You'll get 2 answers. And you will see that even with our graph that we got 17.4. Okay. And now number 8. So, sorry, going back to that one. I don't care how you solve it. And if you use the graph, because I want you to get really good at using these calculators. Yes, there's math involved, and we will have time to practice all of this kind of math as well. But for the ACT and for some of the tests you will have coming up, the calculator and knowing how to use this graphing calculator is super important, and it helps a lot. So that's kind of what we're concentrating on now. So trace it till you get to 500. If that bothers you and you want to make sure you're exact, then use the quadratic formula. Okay, so number 8. It wants us to change from from vertex form to standard forms using the order of operations. Okay, so in order of operations, I need to get rid of parentheses first. Well, this says x plus 5 all squared. So that is the same thing as saying this is x plus 5 times x plus 5, and I still have that minus 1 on the end. Okay, so we need to get rid of these parentheses by distributing everything in this first parentheses to everything in this last parentheses. So the beginning stays the same. I still have y equals 2, and I'm still putting everything that happens here in a parentheses, because that 2 is actually multiplying everything, but I can't deal with it yet. So I'm going to take this first x, and I'm going to multiply it times everything in the second parenthesis. So I'm going to get x squared plus 5x. I have x times x and an x times 5. Then I have to take the second term and multiply it times everything in the second parenthesis. So I get 5x plus 25, and I still have a minus 1. Now in this parentheses, I have some like terms. So I have x squared plus 10x plus 25 minus 1. I now need to distribute this 2 to everything inside that parenthesis. So I'm going to get 2x squared plus 20x plus 50 minus 1. And I have a couple of like terms now. So I'm just going to write it over here. Y equals 2x squared plus 20x plus 49. There is this original equation that I kind of covered up, sorry about that, in standard form. So vertex form to standard form. And now this one, this is where it messed up, and I crossed it off on video 1, sorry, on another problem. But this says, it gives us vertex form. That's not vertex form, that's intercept form, so just ignore that. But we're changing it to standard form. Okay, it still has the same steps. So vertex form, I wrote it out as two binomials being multiplied. Well, now I already have them written side by side, so I'm going to do the same thing. So I still have a y equals 3. I'm going to take x times everything in the second parentheses. So I'm going to get x squared, whoops, that's a minus 2. And then I take the 1 times everything in the everything in the second parenthesis. So I have a plus x minus 2. So in parentheses, I have an x squared minus 2x plus x minus 2. I have these two like terms here. So I have 3 times x squared minus x minus 2, because I have a negative 2x plus x, gives me a minus 1x. And then I distribute this 3 to everything inside. So y equals 3x squared minus 3x minus 6. So there is this intercept form in standard form.